Welcome to Class 7th Science of CBSE. We are in Chapter 15th, Light. You must have studied about light in Class 6th. You already know that the light travels in a straight line. But how do you prove that? We know that light travels along a straight line. Now let us discuss on how to prove experimentally that light travels in a straight line. The simplest method is that you need to have a straight cylindrical tube, like how it is shown on the screen, and a candle. Lit the candle and try to see the candle flame from one end of the tube. Since the tube is a straight, and if you can see from here the flame, that means the light has traveled straight through the tube. It's a simple explanation and experiment to prove that light travels along a straight line. But then if you take a tube which is not straight, look at this picture. Here, tube is not straight, it is curved. Now in this case, if you see this flame, the light travels straight till here, but then it will not be able to take a bend like this and go. So this doesn't happen. And therefore, this person will not be able to see the flame, since the flame is blocked by the tube here. So the light cannot travel if the tube is bent, right? So this experiment tells us that light travels along a straight line. This property of light is called rectilinear property of light. But please remember, light appears in different ways. So one of its property is rectilinear property, that is movement on a straight line. In the future, you will come to know the mode of travel of light in different ways. But when light travels and falls on a mirror, what happens we shall study. If you go to a salon for hair cutting, you will find the light which is just above the head will fall on our face, our body, and then it will be reflected back, right? And this is what the mirror. So this light here falls on our body and it reflects on the mirror. So here in this picture, I have shown you only one ray. It can be plenty of rays. When the light falls on our body and then it is sent back on the mirror, so this is the mirror, we see an image there. What happens when light falls on a mirror? We don't see image if a light falls on a wall, a rough wall, on a rough surface, but we see image when it falls on a shiny or a smooth surface. Now, as far as mirror is concerned, how can you show it on a piece of paper? We can't draw a, a rectangular mirror and draw all the ray diagrams. The simplest way to draw the mirror is just draw a straight line and then you know that on one side of the mirror it's a rough side. You can just make it this way. So this is a smoother side of the mirror and this is the rough side of the mirror. Just recall all the mirror which we use in our house. So one side there will be a smoother side, another side there will be a rough surface. So when you see from here, we see our image, which means the light which falls on us will be sent back and then the mirror puts our image inside and that we shall see. So when the light falls here, it reflects back. This property of light is called reflection of light. Please remember, it is because of reflection of light we see things around us. We see image. When the object is placed, for example, this is an object. In front of the mirror, this is a mirror. We see its image. Now recall, when we stand in front of the mirror, we see our complete image inside the mirror. What are the properties of this image? Will that image exactly appears as object? First, we need to understand in this picture which is the object and which is the image. The one which is placed here is an object and the mirror shows you a picture of this object called image. Now let us study how different image is from the object. Let me repeat, how different image is from the object in the plane mirror. You must have seen an ambulance and the name of the ambulance or the word ambulance which is written on that vehicle will be a mirror image. Look at this. And what do you mean by mirror image? When we stand in front of the mirror, Just try this activity. Lift your right hand and watch. Your image will show you that you have lifted a left hand. You raise your left hand, your image will show you a right hand. And it is vice versa. Our left appears as a right in the image, or right appears as a left in the image. So you will find that in the mirror, the right appears as left and the left appears as right. Note that only sides are interchanged, but the top doesn't appear as bottom, right? A top appears as top only and the bottom appears as bottom only. So therefore there is no interchange of top and bottom, only sidewise. And we shall see what is this property called as. The mirror shows us the image which is different than the object, but not inverted. What do you mean by inverted? If a head is shown at the down, then it is inverted. Okay, but here only sides are changed, and that is what called lateral inversion. So what is lateral inversion? Lateral inversion is the reversal of mirror image where the right side of the object appears as a left side in the mirror. Right? We have already studied the process of reflection, but if you are asked to draw how the light reflects, how will you draw? First of all, we know that how to draw the mirror. So what is this rough side indicates? It is the back side of the mirror, and this one is the smoother side of the mirror. Now you need to have a scale, right? So not only scale, you need to have the protractor also. Now we'll go ahead with a drawing. So what I'll do is I'll keep this here horizontal. You can keep even vertical. So let us try horizontal and take a scale and draw with the help of pencil a light ray. Okay, so this is straight. We know that light travels in a straight line, so we need to draw a straight line. But remember, we have drawn an arrow mark here, and when you draw an arrow mark, it means it's a light ray. Well, when you draw a first light ray on the mirror, what is that light ray called? And that is called incident ray. So we have completed drawing of incident ray. When the light falls on the surface of the mirror, right? It falls, let us say that somewhere here. It reflects. So we can take, a scale and draw the reflected ray. But will this be correct procedure? Should we draw a reflected ray in this way? Or the earlier one is correct? Or should we draw the reflected ray in this way? All these things represents a wrong picture. So what we should do? So we need to follow the properties of reflection, and here we need to use a protractor. But first of all, this particular point, okay, don't consider this line, it's a wrong reflection. This particular point where this light ray falls is called, right, point of incident. So to draw this diagram, you need to have a scale. And then let's suppose that you have also a protector. And then till here our diagram is correct. From here what we have to do, keep your scale with you and also a protector, and keep the protector properly at the point of incident. Look at this. Now when you keep the protractor at the point of incident, locate this 90° on the protector, make a mark there. Now please look at how it is placed, right? So it is exactly, a point is marked there at 90°. This is 90° of the protector, and then you have to draw a line which is perpendicular, okay, and that perpendicular you need to show as dotted line. Please remember, how did we draw this line? This is not a ray, it's a perpendicular to this surface. When you draw this properly on a plane surface, then that dotted line is called, okay, see, it's a exact perpendicular, and that is called normal. Please remember this, right? And to draw this we have to use always a scale as well as a protector. Now keep the protector back. Here we need to draw a reflected ray, right? What is normal? Normal is a perpendicular drawn at the point of incident, right? So this is the point of incident, and normal is the perpendicular draw at the point of incident. And what is perpendicular? So if you, this angle is 90°, right? So that is 90°. Okay, therefore it is called as normal. Now keep your protector back, and then, okay, find out the angle here and keep this back. Locate the exact angle. Suppose from here to here, if you can measure, you have to measure somewhere from here to here, so it comes somewhere here, right? So it should be a same angle here, and then you have to make a point and draw the line. Okay, so that is what you have to do. So you have drawn the line, and how did you draw the line? You have kept the, look at this, this is how you have made a line, right? And this is our diagram. So if you keep this protector properly, you will find this angle, okay, and this angle comes correct. So what is this angle called? This angle called angle of incident. Remember this, because it is between incident ray and the normal. So if this is called angle of incident, what will this called? This will be called angle of reflection. So it is very simple now. If you properly draw this and make a mark somewhere here and here and write angle of incident as angle I and angle of reflection as angle R, so your diagram is complete. And if your diagram shows angle I is equal to angle R, then you get full marks for the drawing. So these angles are very important, and that you should use for that protractor to draw, right? So in the next video we shall see how can we represent the loss of light on this using this diagram. Thank you.